to meet you once again for this module 4, that is legendary differential equation. All differential equations we cannot solve and we cannot get the solutions analytical. And some of the differential equations we may get the series solution. Such equations are Bessel differential equation and legendary differential equation. How to get this Bessel and legendary differential equation? That's the Laplace equation del square u equal to 0. If orthogonal curvilinear coordinate system is of great importance in many physical and engineering. In cylindrical system is called the Bessel differential equation, and the solution of this Laplace equation in spherical system is called the Legendre differential equation. That is, the ordinary differential equation, which is of the form f1x y double dash plus f2x y dash plus f3x y equal to 0, where the coefficient of y double dash and that is f1 of x, f2 of x, f3 of x are polynomial in x. Then the solution of such equations we can find using infinite series. How to choose the infinite series solution? The coefficient of y double dash, that is f1 of x, is not equal to 0. When x is equal to 0, then we can assume the solution y is equal to sigma r is equal to 0 to infinity a r x power r. If the coefficient of y double dash is not equal to 0, when x is equal to 0, we should choose the solution as like this. Suppose the coefficient of y double dash, that is f1 of x, equal to 0, when x is equal to 0, then we should choose the solution as like this. Correct? That is y is equal to sigma r is equal to 0 to infinity a r x power m plus r, where the very first term, that is when r is equal to 0, this expansions will be a naught, you will get the first term, which is not equal to 0. And the value of m, a naught, a1, a2, etc. all are constant, which we have to find. Now we'll go for legendary differential equation. That is the series solution of legendary differential equation. Consider the legendary differential equation 1 minus square y double dash minus 2x into y dash plus n into n plus 1 of y equal to 0. This is the legendary differential equation. Then how to choose its solution? By taking the coefficient of y double dash. Here, y double dash coefficient is 1 minus x square. The value of 1 minus x square will not be equal to 0 when x is equal to 0. You apply x equal to 0. What is this 1 minus x square will be 1, which is not equal to 0. So we should choose the series solution as the first type. That is y is equal to sigma r is equal to 0 to infinity a r into x power r, where a naught is not equal to 0. Now, after choosing this solution, what do you have to do? To put the value in this equation, we need y double dash, y triple dash, y dash, y dash and y double dash. That is, we have to find out the first order derivative and the second order derivative. What is y dash? Dy by dx. How to find out dy by dx? Differentiate this with respect to x. X is only here. So the derivative of x power r is r into x power r minus 1. Now I am going to find out y double dash. How to find out y double dash? Derivative of y dash. What is derivative of y dash? Differentiate this with respect to x again. Here x is where? X power r minus 1. Differentiate this x power r minus 1. What is derivative of x power r minus 1? R minus 1 into x power r minus 2. Thus we have obtained y double dash and y dash. Put the value of y double dash, y in equation number 1. So what is equation number 1 will be 1 minus x square into sigma r is equal to 0 to infinity a r minus 1 x power r minus 2. Put the value of y double dash. Minus, in this equation, minus 2x y dash. So minus 2x into, what is the value of y dash? Y dash is sigma r is equal to 0 to infinity a r into x power r minus 1 plus n into n plus 1 of y. What is the value of y? Sigma r is equal to 0 to infinity a r into x power r. Thus, we have obtained this line by substituting in equation number 1 the value of y double dash, y dash and y. Now, I am going to split this into two terms. That is 1 into sigma and minus x square into summation. 1 into any number, the same thing. That is sigma r is equal to 0 to infinity r minus 1 into x power r minus 2 minus this minus x square into this. I am multiplying this x square inside. Here already x power r minus 2 is there. Into x square will be add the power 2 plus r minus 2 is r. Minus this 2x I am bringing inside the summation. That is sigma r is equal to 0 to infinity. 2 into r. This x into x power r minus 1 is x power r. Plus n into n plus 1 is a constant which I am not taking inside summation into ar x power r. Thus we have obtained 4 terms. First one, second one, third one, fourth one. 4 terms we have obtained. Out of these 4 terms, 3 terms are of similar coefficient we have got. See that x power r, x power r, x power r. Here x power r minus 2. So the x power r minus 2 I am keeping aside. I am not doing anything. That I am going to keep the same. And x power r is common. So I am taking summation r is equal to 0 to infinity. One ar is also common. X power r, which is also common, I am taking outside. So what is left out? R into r minus 1 minus 2r plus n into n plus 1. Since I have taken minus outside, this will be negative. Minus of, I have taken minus of sigma r is equal to 0 to infinity. Minus I have taken outside. So this will be positive. That is the first term is positive. Second term also positive because I have taken minus outside. And the third term will be negative because minus is outside. Now I am going to expand this inside the floor bracket. What is this? R square, that is the first term, minus r. R into minus 1 is minus r, plus 2r is plus r. Minus n into n, n square. Minus n into 1, minus n. Okay. Once again, r square minus r plus 2r is plus r. Minus n square minus n equal to 0. Now, this r square minus n square, I am keeping one term. R square minus n square is one term and r minus n is other term. So what I'll get? I'll get the next line. That is r square minus n square plus n minus r. Now, this r square minus n square is of the form a square minus b square, whose value is a minus b into a plus b. Thus, I'll get r minus n into r plus n. Okay. This is one term now. This is another term. From these two terms, r minus n is common. You take r minus n common outside. So what is left out here after taking r minus n outside? R plus n plus 1. Correct? Thus, I have got my next line is sigma r is equal to 0 to infinity r minus 1 x power r minus 2. The first term, nothing we have changed. We kept it as same. Minus sigma r is equal to 0 to infinity ar x power r. After taking r minus n outside, here r plus n plus 1. Correct? This is the summation we have obtained. Now, I am equating the coefficient of x power r to get the recurrence relation. To write the recurrence relation, I wanted to equate the coefficients of x power r to be 0. X power r, when will you get x power r here? If I am replacing r by r plus 1, I'll get x power r. When will you get here x power r? Already it is obtained. So as it is, we can write. And here, to obtain x power r, I have to replace r by r plus 2. So what is the coefficient of x power r here? A r plus 2, r plus 2, r plus 2 minus 1 is r plus 1. Minus of ar, r plus n plus 1 into r minus n. We have obtained. From here, I am going to write a r plus 2 term. That is a r plus 2 will be, bring this negative terms to the other side, that will be positive. That is r plus n plus 1 into r minus n divided by these two factors. That is r plus 2 into r plus 1 into this ar. This is the recurrence relation. Now, from this recurrence relations, I am going to find out the value of a2, a3, a4, a5, etc. If I substitute the value of r is equal to 0, I'll get a2. 1 I'll be getting A3, 2 I'll be getting A4, 3 I'll be getting A5. So you substitute the value of R is 0, 1, 2, 3, 4, 5, etc. in equation 3, that is the recurrence relation. We get the solution as A2 is equal to R is 0. A2, how will you get A2? If R is 0, that is the first term. That is 0 plus n plus 1, n plus 1, 0 minus n, 0 plus 2, 2, 0 plus 1, 1 into A naught. Okay, by taking minus outside, I'll get minus of n plus 1 into n divided by 2 into 1 is 2 factorial into A naught. 3. How will you get 3 here? 3 to get, I have to apply R is equal to 1, second term. So you apply R is equal to 1 throughout this equation. So what will you get? A3 is equal to R is 1. 1 plus n plus 1 is n plus 2, the first term. 1 minus n, the second term. 1 plus 2, 3. 2, 1 plus 1, 2. 3 into 2 into A1. Correct? The numerator have written as it is. The denominator 3 into 2 have written 3 factorial. Correct? 3 into 2 into 1 is 3 factorial into A1. Now A4, how will you get A4 here? R is equal to 2. So you substitute the third value, R is equal to 2. So you will get A4 is equal to 2 plus n plus 1, n plus 3, 2 minus n. You will get the second term, 2 plus 2, 4, 2 plus 1, 3, 4 into 3 into A2. But A2 value already we have obtained here. So this value I am applying. In place of A2, I am going to apply minus n plus 1 into n by 2 factorial into A0. This value I am going to apply. So what will you get? N plus 3 into n minus 2 minus n. This minus will come outside. N plus 1 into n divided by 4 into 3 into 2 factorial. That is 4 factorial. Correct? Of A0. Similarly, we'll get A5. A5 is by substituting n is equal to 3. So 3 plus n plus 1, n plus 4, 3 minus n, you will get 3 plus 2, 5, 3 plus 1, 4, 5 into 4. Into, when R is 3, you will be getting A3. Substitute the value of A3 here. What is A3? N plus 2 into 1 minus n divided by either 3 factorial you can write or 3 into 2 you can write. Into A1. Now I'll multiply the numerator completely and denominator completely. What will you get? N plus 4, n plus 2, 3 minus n, 1 minus n divided by 5 factorial into A1. Correct? Thus we got the value of A2, A3, A4, A5. Correct? Now I am assuming the series solution which we have chosen in equation number 2. What is equation number 2 implies? Y is equal to sigma R is equal to 0 to infinity AR into x power R. You expand this by substituting R is equal to 0 to infinity. What will you get? A naught. When R is equal to 0, A naught x power 0. That is A naught. When R is equal to 1, you will get A1 x power 1. That is A1x. When R is equal to 2, you will get A2 x power 2. That is A2x square. When R is equal to 3, you will be getting A3 x cube. You will get etc. Now substitute the value of A2, A3, A4, A5 from the above relation. Correct? Just you apply the value of A2, A3, A4, A5 value. See now this expression. Here the alternative terms are dependent upon A0 and A1. See that first term, third term, fifth term are dependent upon A0. Second term, fourth term, sixth term are dependent upon A1. So I am collecting A0 separately, A1 separately. That is A0 of, after taking A0 common outside, what is left out from the first term? Only 1. What is left out from the third term? Minus of n plus 1 into n divided by 2 factorial into x square. What is left out from the fifth term? Minus of n plus 3 into n plus 2 into 2 minus n into n divided by 4 factorial into x power 4 plus etc. Because it is infinite series. Now again, I am taking A1 common outside plus A1 of, what is left out from the second term? Only x. What is left out from the fourth term? N plus 2 into 1 minus n divided by 3 factorial into x cube. That I am writing. From the last term, what is left out after taking A1 outside? N plus 4 into n plus 2 into 3 minus n into 1 minus n divided by 5 factorial into x power 5 plus etc. Correct? It's a infinite series. That is A0 into this infinite series, I'm writing it as y1, that is the first solution, plus a1 into this infinite series, I'm writing the second solution, y2. Thus, we have obtained y is equal to a0 into y1 plus a1 into y2, which is the complete general solution of Legendre differential equation. Thank you.